Hello everyone, welcome to this first module of Activity 3, entitled Evaluation of Acceptability Thresholds for the Main Quality Traits for Different RTB Food Products of the RTB Breeding Project. This presentation was made by DEUSCHER and Christophe BUGAUD from the CIRAD in Montpellier and ADINSI Laurent from the University of Abomey-Calavi in Cotonou. In this first module, we will present all the steps required to determine acceptability thresholds. The details of each step will be presented in other modules that we will send you at a later date. This first module, presented today, concerns the general aspect of acceptability thresholds. The second module deals with the choice of sensory attributes and sampling. Module 3 deals with consumer testing. Module 4 will present descriptive quantitative analysis and instrumental analysis. And Module 5, we will explain how to calculate acceptability thresholds. And finally, Module 6 will show you hybrid selection. We will start this first module with a reminder of what acceptability thresholds are and the purpose of calculating them. The acceptability thresholds we are going to talk about today are defined and calculated according to the publication of BUGAUD and al. Published in 2016. According to this publication, we can define the acceptability thresholds of a sensory attribute of a food as the minimum and/or maximum level of intensity of an attribute considered acceptable by consumers. The first step in setting up the calculation of acceptability thresholds for a food is to choose the sensory attributes. The steps involved in this choice will be detailed in Module 2. The choice of sensory descriptors obviously depends on the product studied. Normally, in the context of this project, the sensory attributes of the various product studies have already been defined in RTB food product profiles. To calculate the thresholds, we need to select a maximum of 4 or 5 sensory attributes, the most characteristics of the foods. Then, establish a clear definition list for selected attributes. It's very important to define the sensory attributes clearly and to ensure that they are well understood by the various people who will be carrying out the tests, and that they are also easily understood by naive consumers. Still in Module 2, we will discuss the choice of varieties to be studied. A minimum of 6 contrasting varieties must be selected. It is essential that the selected varieties are contrasted for all the selected sensory attributes. Then, to carry out the analysis, we need to use the same raw materials for all the analysis, whether consumer tests, QDA, or instrumental analysis. Finally, the experimental plan for sample presentation must be adapted on a case-by-case basis, depending on the location of the study, the number of interviewers available, the number of varieties selected, and the number of consumers targeted. For example, if more than 6 samples are selected, it will not be possible to present all samples to all consumers, and the experimental plan will have to be adapted. In Module 3, we developed the consumer test, also known as the hedonic test. Its aim is to determine the appreciation and acceptability of products by consumers. As a reminder, to carry out this type of test, it is necessary to question a minimum of 100 naive consumers, representative of consumers of the product under study. I recommend interviewing 125 of them to make sure you have enough complete data. It's preferable to carry out the consumer test in only one location. The hedonic test is an outdoor test, which means that it is not carried out in a sensory analysis laboratory. As this test is carried out outside the laboratory, It requires a large team for logistics, ideally a minimum of 6 to 10 people. During a consumer test, consumers are asked 3 types of questions: an overall liking question for the product presented, a jar test type questions, and questions on personal information, gender, nationality, age, or eating habits. Consumers should perform all the tests in the questionnaire on one product. Each product must be tested in the order given by the questionnaire, one after the other, until all the products will be tested. It's important not to present more than 6 products to a consumer to prevent them from getting too tired and not answering the questions correctly. I'm now going to describe the different types of questions in the consumer test. The first question, as I said earlier, is what we call overall liking. It's about giving an overall assessment of the product, taking into account all its sensory properties. Consumers are asked to give a score on a scale from 1 to 9, corresponding to their overall appreciation of the product in its entirety. You can see here an example of the scale used for boiled plantain. After tasting the sample of boiled plantain, consumers are asked to give a score from 1, which corresponds to dislike extremely, to 9, which corresponds to like extremely. The second part of the consumer test is the jar test. JAR stands for just about right. It's a test that measures the appropriateness of the level of a specific attribute and are used to determine the optimum levels of attributes in a product. Consumers are asked whether a sensory characteristic of a product is too high, too low, or just about right compared to their ideal or to what they usually like. This test is recommended for 2 to 5 important characteristics. As in the previous slide, here is an example of presentation for boiled plantain. In this case, 3 sensory attributes are studied: color, firmness, and wetness. The last part of the questionnaire concerns general questions. You can ask to the consumer about nationality, age, level of education, marital status, occupation, and ethnicity. It's also important to ask about the consumer's eating habits. How often do they eat the products you're studying? How do you eat it? With what other ingredients? At what time of the day? Etc. This slide shows a fictitious example of the results that can be obtained from a jar test. On this table, you can see the raw data of a study. The rows correspond to the consumers and the sample. Here there are 5 consumers, and this table concerns sample number 1. For each descriptor in the columns, we put a score according to their response to the jar. The note 1 corresponds to not enough or too low, the note 2 to just about right, and the note 3 to too strong or too much. Once all consumer responses have been entered into the table, it is possible to calculate the percentage of consumers who ticked not enough, just about right, or too much for each descriptor. Once this has been done for each sample, it's possible to create tables by descriptor. For example, in this table, for firmness, we can see that in sample 1, 24% of consumers ticked the box corresponding to not firm enough, 60% ticked as I like, and 16% ticked too firm. We will see later in this module how to use this jar test data. We now move on to the module number 4, which corresponds to the quantitative descriptive analysis, also known as QDA. Unlike the hedonic test we have in the previous slides, this is a descriptive test that gives information on product characteristics using the human subject as a measuring instrument. This test provides analytical data on products and are carried out in the laboratory. To perform these tests, it's essential to have a good trained panel with a minimum of 12 trained judges. If the panel is not trained and therefore not repeatable, discriminating and in agreement between the different judges, the results of this analysis are not usable. In these tests, each panelist is asked to rate the intensity of the descriptors from 0, which correspond to absent, to 10, very strong. These tests will be carried out on the same sensory attributes as those used in the JAR test in the consumer test. Each judge will study all the samples. Depending on the number of judges in the panel, it will be necessary to repeat the samples. Finally, for this study, it's very important to use the same plant material as that used for the hedonic test described above. You can see an example of questionnaire layout for QDA analysis. For each sample, you are asked to circle the number corresponding to the intensity of the descriptor you perceive in the sample. For example, for firmness, the respondent is asked to circle an intensity between 0 and 10, where 0 corresponds to not firm and 10 to very firm. After performing a QDA analysis, here is the type of results you get. The first column of the table shows all the panelists from 1 to 12 at least. In this example, they tested sample number 1 and did 3 repetitions of this sample. Here, for example, the first panelist for the first repetition of sample 1 found that the sweetness had an intensity of 7, the firmness an intensity of 2, and the moisture content an intensity of 4. To process the data, you need to enter data for all panelists for all repetition of one sample. We can then calculate the average intensity for each attribute in the sample. This exercise must be carried out for all samples so that the data from the various samples can be compiled in a table as shown here. Still in Module 4, we will be taking a brief look at the precautions to be taken when using instrumental methods. These methods are carried out in the laboratory and must be performed on the same plant material as that used for the hedonic test and the QDA. It's important to make measurements that correlate with the sensory attributes studied previously. The methods selected to make the measurements must be simple for breeders to use and therefore quick, inexpensive, and easy to set up. In addition, they must be repeatable and reproducible. Once the instrumental measurements have been made, it's possible to make correlations between the sensory measurements of the attributes and the instrumental measurements. This work was carried out in the RTB Food WP2 and is ongoing in the first RTB breeding activity. For example, in the publication of Laurent and ADINSI, for sweetness, they made correlations between JAR analysis, QDA sensory scores, and sugar dosage in the raw material. Once the sensory and instrumental measurements have been taken, they can be processed to establish acceptance thresholds. The methods for calculating these thresholds will be the 5th module. To calculate the thresholds, we can take the data from the JAR test and the QDA that I presented earlier. At the top, you will find the JAR data table and at the bottom the QDA data table. You then need to create a new table for each attribute. Here, we have taken the example of firmness. In the rows are the values of the various samples studied. The first 3 columns correspond to the JAR test data. The 4th column corresponds to the average QDA value, and the last column to the instrumental measurements. Once this table has been created for each sensory attribute studied, it's possible to create a scatter plot. The example shown here is a fictitious one. Here you can see a scatter plot of the QDA firmness score as a function of the percentage of people finding firmness just the way they like it in the 6 samples studied. This scatter plot allows us to draw a bell curve. We arbitrarily decide that to calculate the acceptability thresholds, 60% of the population must be satisfied. From the curve, we see in green that for 60% of the population to be satisfied, the intensity of firmness in the product must be between 3.9 and 6.7 on a scale from 0 to 10. Using the same calculation principle, it is possible to calculate the optimum thresholds. For this, we assume that 70% of the population must be satisfied. To have an optimal threshold for this product, the firmness intensity according to the QDA analysis must be between 4.6 and 6. For some sensory descriptors, we don't get a bell curve but a straight line, as you can see here for banana aroma. This means that the more intense the aroma is, the more consumers appreciate the product. Even if there is no bell curve, it's possible to calculate thresholds. For the acceptability thresholds, aroma intensity must be above 4.8, and for B optimal, it must be above 6.2. It's from the various curves I've just presented that it's possible to obtain this type of graph. This image comes from BUGAUD et al. 2016 publication on desert banana. In this article, 5 sensory attributes were studied: mealiness, firmness, banana aroma, sourness, and sweetness. In green are the ranges corresponding to acceptability thresholds, and in pink, the optimal thresholds. Once the instrumental measurements corresponding to a sensory attributes have been taken, they can be used to calculate the thresholds. This time, on the scatter plot, the abscissa will show the values of the instrumental measurements and the ordinates, the data from the jar test. In this example, we again have a bell-shaped curve for firmness. We can see that if we want 60% of the population to be satisfied with the firmness, it has to be between 1.6 and 2.8 newtons, which corresponds to the acceptability thresholds. The optimal thresholds is between 1.9 and 2.4 newtons. As before, following the creation of these point clouds and thresholds calculation, we can have this type of realization, but this time the intensity no longer corresponds to sensory intensity, but to instrumental values. In the publication of BUGAUD et al., for example, he established acceptability thresholds for this desert banana firmness by measuring penetrometry in newtons and thresholds for acidity by measuring titrable acidity. Once all the thresholds have been calculated, they can be integrated into selection program. Here is an example for desert banana with 3 descriptors: mealiness, firmness, and sweetness, for which acceptability and optimal thresholds have been calculated. The table shows several varieties with their perceived intensity score for the 3 descriptors. Scores in green indicate that the intensity is within the range corresponding to the acceptability thresholds, and in pink within the range of the optimal thresholds. For a banana variety to be considered acceptable, all its scores must be in green, and for the variety to be optimal, all 3 scores must be in pink. Thus, applying this rule, in our example, there is only one ideal banana variety with all the sensory attributes in the optimal range for consumers, and 5 acceptable varieties out of the 132 varieties. This method of thresholds calculation, therefore, makes it possible to integrate consumer preference into selection program. This first module is now over. I wish you a very good day and hope to see you soon for the next module. Thank you.